This is October, November 2022, variant 42 question. 1A, you have to define gravitational field. One of the ways to define gravitational field is to say that the gravitational field is a field of force, and it is defined as the force per unit mass. This is how it's get on. This is one way of getting the definition for gravitational field. For part B, a spherical planet can be considered as a point mass at its center. On figure 1.1, draw gravitational field lines outside the planet to represent the gravitational field due to the planet. For this question, we need to know how to represent a gravitational field. A gravitational field can be represented by drawing gravitational lines of force, like this. In order to score the 2 marks, you must draw lines of force which are radial and is perpendicular to the surface of the sphere. So the lines will be pointing towards the center of the planet. And then you must put the lines must have arrows pointing towards the planet. So you need to have arrows. This is how you get the 2 marks. 1 mark for drawing the lines, 1 more mark for showing the arrows. Then for part 2, a satellite is in circular orbit around a planet. Explain with reference to your answer in B part 1 why the path of the satellite is circular. To answer this question, we need to know the condition for an object to undergo uniform circular motion. For an object to undergo uniform circular motion, there must be a centripetal force that is perpendicular to the velocity of the object at any moment. And then you must know that the gravitational force provides the centripetal force. And the centripetal force is always perpendicular to the direction of the velocity. Since the gravitational lines of force are radial lines that we draw here, these are radial lines. Radial line means they go towards the radius, towards the center of the planet. So to get the 2 marks here, the first mark is to say that the radial field line shows that the force of acting on the satellite, which is the gravitational force, is pointing towards the center of the planet. Or you can say that the velocity of the satellite is perpendicular to the field lines. Number 2, second mark, the gravitational force is perpendicular to the velocity, and this causes centripetal acceleration. Part C, the object rests on the surface of the Earth at the equator. The radius of the Earth is 6.4 times 10 to the power 6 meters. To answer this question, we need to know that the Earth takes 24 hours to make one rotation. Therefore, we know that T is 24 hours. The period of the object is also 24 hours. When we want to determine the centripetal acceleration, so the equation the equation for acceleration, centripetal acceleration, must have T, which is 24 hours. So we can use A equals to V squared over R and V equals to 2 pi R over T. Or we can use A equals to R omega squared, where omega equals to 2 pi over T. So you substitute either your V into your A equals to V squared over R, or omega equals to R omega squared, you'll get A equals to 4 pi squared R over T squared. And then you substitute the values of R and T into the equation for A. You'll get 0.034 meter per second squared. So that is a centripetal acceleration. Then for part 2, describe how the 2 forces acting on the object give rise to this centripetal acceleration. You may draw a diagram if you wish. C is the center of the Earth. To answer this question, you must understand that there are 2 forces acting on the object, the gravitational force and also the normal force or the reaction force. The resultant of these 2 forces must act towards the center of must act towards C. And the resultant force is called the centripetal force. So to get the 2 marks for this question, we say that 2 forces acting on the object are gravitational force F and the normal contact force N. The 2 forces are in opposite directions, and the resultant of these 2 forces causes the centripetal acceleration. And then this is a summary of the facts that you must know to do this question. Number one, you need to know how to represent and define gravitational field. Number two, you must know how a gravitational force leads to circular motion. Number three, how to calculate acceleration using r and t. And then number four, for an object to have circular motion about the Earth, there must be a resultant force acting towards the center of the Earth. This resultant force provides a centripetal force needed for the object to undergo uniform circular motion.